All right, welcome to tonight's office hour, and I think it's time we just hop right in. All right, so in number one, make this a little bigger. Okay, so we're going to focus on one variable statistics tonight, and here we got a couple box plots, and it says what must be true. So the first thing is a box plot is like another like it's called a five number summary where we have the min, the max. Q1 or the lower quartile, Q3 or the upper quartile, and the median. There's no mean. We have no idea how many data points there are. All we know is those five numbers. So anything that's mentioning the mean is just, we're not going to know from a box plot. And then, like I said, this number, this one in the middle is the median. So clearly the median for variety B is greater than that, or the median for variety A is less. So the answer is C. All right. It's not like a hard problem to do, but sometimes you haven't done box plots since like seventh grade, and they probably called them box and whisker plots. So um, this is, you just need to know where everything is. So median is the biggest thing we're going to get from this. We could also get range. We could get interquartile range. So there's things you can get from a box plot, but a mean is not one of them. All right, on to number two. So data set B is 10 positive integers less than 75, and the list shown gives nine of the integers. Okay. And the mean of these nine integers is 56. So they're just kind of helping us out there. And the mean of the data set B is an integer greater than 56. So that means the number that we're missing has to be greater than 56, because if you add a number greater than the mean, it will bring the mean up. What is the value of the largest integer from data set B? So one thing we know is that these nine integers, if we do 9 times 56, because if the average is 56 and you multiply by 9, the sum of those integers is 504. And then we're adding some extra integer. Okay. And then we're going to divide by 10 now, because now there's 10. And that's going to give us this is going to be the average or the mean of data set B. And we need that mean to be greater than 56. Um, and we can't add a number that's less than 75. I'm sorry, we can't add a number that's bigger than 75. And the other thing is that we have to find what the largest integer is. All right. So it's probably the integer we're adding, right? Like we're going to just add a number bigger to 62. So basically, we need the largest integer such that when we divide these, um, it's greater than 56, but the number that we're adding is less than 75. Um, this is interesting. I think what I would do is, yeah, so I need it to be divisible by 10. So I'm just going to like think of numbers that I would add to be divisible by 10. So first of all, it has to be a number that ends in a 6, because when I do 504 plus a number that ends in a 6, then I will get a number that is divisible by 10. And it can't be 76 because it has to be less than 75. So then it must be 66, right? So 66, because if I do that, if I do 504 plus 66, I get 570. And 570 divided by 10 is 57. So there we go. And that is a mean that's bigger than 56. And the number itself, the largest number in the data set, is less than 75. And that'll be it. So any other number from 66 to like 74, let's say, will, when I add it, won't give me a number divisible by 10. And I need it to be divisible by 10 because I need the mean to be an integer. All right. So this is a pretty tricky one. So again, people send these to me and I'm like kind of looking at some of these for the first time. So that's just kind of how I worked my way through it. I just figured this expression out and then I needed it to be an integer. So I figured out what I could add that kind of fit the parameters of the problem. All right. So again, the final answer is 66. Okay, so here let's kind of zoom in on this one. So here in number three, we have two different data sets and two different frequency tables. Um, which of the following compares the means? So basically, we could find the means of each one, but we don't want to have to. So if you think about how this works, like if we were to find the mean of the first one, that would mean there's eight 15s and six 20s and five 25s. So basically we do 8 times 15 plus 6 times 20 plus 5 times 25 plus 4 times 30 plus 2 times 35, and then we would divide by the total. But since they're both going to have the same total, like this one clearly has numbers, right? The frequencies are bigger for the bigger numbers. So data set Q is going to have a larger mean. So the mean of data set P has to be has to be less than the mean of data set Q. Um, yeah, that's it. So since the larger frequencies have the larger values, you're just going to have a larger mean. You could find the mean there, but I don't think you need to. It would be wasting, I think, a lot of time. All right, number four. All right, so we have 39 distinct values. A set of 39 distinct values, a mean of 84 and a median of 84. Okay. The new data set is formed by increasing each value in the original set that is greater than the median by 15 and decreasing each value in the original set that is less than 15 or that is less than by 15. Okay. Which of the following measures does not have the same value in both the original and new data sets? Okay, so if there's 39 distinct values, then it's an odd number of numbers. So that means there is a definitive median. I don't know if that really matters, but so then all the values above it and all the values below it, if we add 15 and then subtract 15 from the same number of numbers, then the sum of the values is not going to change. And if the sum of the values doesn't change, then the mean's not going to change because we'll be still dividing by 39. Um, and also, the median's not going to change because you're going to have a middle number and you're going to move all the numbers above it higher and all the numbers below it lower, but the middle number is going to stay the same. Um, so the answer is the standard deviation because what's going to happen is you're now going to have all the numbers are going to get further from the mean and you're just going to increase the standard deviation. All right, number five. So we have data set X and data set Y, and which of the following is true? So the median. All right. So if you have symmetric data, so both of these are symmetric, right? They're the same on the left as they are on the right. When you have symmetric data, the median will just be literally the middle of so the median is going to have to be three. It would also be the mean as well, but I don't think the mean is related to this problem. All right, so the median is equal. So one is definitely true. You could figure it out by counting or whatever, but if it's symmetrical like this, the middle number is going to be the mean. Or sorry, that is also true, but we don't need the mean. The middle number will be like the median. And I mean the middle of these numbers. If this was skewed, then that would not be true. The middle of these numbers. I know the median is the middle, but I mean the middle of the values at the bottom here. Okay, the standard deviation of data set X is greater. Okay, so to find standard deviation, what you want to do is locate kind of how many values are on the ends. So this one has six values at the end, and this one only has two. So the one that has more values that are further away, with all things else being equal, given that they're going to have the same mean and they're going to have um, all the numbers at the bottom are the same, then the one on the left is going to have a larger standard deviation because it has more numbers that are further from the mean. Um, so the standard deviation of X is greater. That is true. So it is 1 and 2. All right, so we got data set A and data set B. There are 25 integers in each. In data set B, the first interval represents the frequency of integers that are greater than or equal to 12, or sorry, 10. Okay. They're just telling us that like this interval here, it's greater than or equal to 10, but less than 20. So we're including each one, we're including the number on the left, but not the number on the right. What is the greatest possible difference between the mean of data set A and the mean of data set B? So I'm trying to think of, all right. So if we want greatest possible difference between the means, we, well, clearly data set A is going to have a larger mean, okay, because it's it's got all the numbers are bigger. So what I'm going to do is I'm going to make data set A. If I want the largest difference, I want to make data set A as big as possible and data set B as small as possible. So this means for data set A, I'm going to do 4 times um, okay, this is yeah, so I'm going to do 4 times 29 because I'm trying to make it the largest possible because it can't be 30, so it's between 20 and 29. It's got to be an integer. So then I'm going to assume this is 6 39s, and then I'm going to assume that this is, whoops, 8 49s, and then this last one is 7 59s. And then I'm going to divide that by 25. So let me do that real quick in the calculator. And I get 46.2. And then I'm going to do the opposite in data set B. If I want the largest difference, I want data set B to be the smallest possible. So I'm going to do 4 times 10, right? So I'm going to want to be small as possible. Then 6 times 20, I'm going to run out of room here. And then 8 times 30, and then 7 times 40. And I'm going to divide all that by 25. So I get 40 plus 120 plus 240 plus, and I get 27.2. So if I subtract them, I get 19. All right. So by making data set B as small as possible and making data set A as large as possible, I find the biggest difference that they can have, which is 19. Okay. All right. So the frequency distribution above summarizes the data. Okay, so B we don't know, but we do know it's a positive integer. How much greater is the mean of the set than the median? Okay. So here's how we're going to do this. So the way we're going to find the mean is you just multiply the frequency by the value for all of them, add them, and then divide by the total. So that means I'm going to have 6b plus 12 times 4b is 48b plus 18 times 8, which is 144b, and then 24 times 4, which is 96b, and then 30b. And that's all going to be divided by, well, if I add these up, we get 5b, 13b, 17b, 18b. Now, basically, what happens is the b's all just cancel out. So let me figure that out in the calculator. So we get the mean to be 18. Okay. Now I am seeing a shortcut, but I'll get to that in a second. So now if we think about the median, well, this is symmetrical. So this is what I missed before. So it's symmetrical. So the median just has to be 18 as well. And if you how much greater is the mean and the median? It was not greater. It's zero. So I could have done this problem more quickly and I didn't need to do any of this. When you have symmetrical data, so these are all evenly spread out 6, 12, 18, 24, and 30. And then I have B with B and 4B with 4B and 8B. So it's symmetrical. The mean will always equal the median. All right. So I wasted a lot of time over here. So just look for stuff like that. A lot of these you don't have to calculate, but I made that mistake. So now I know that the mean and the median are the same. So then the difference will just be zero. Okay, so the mean, 10 pumpkins was 18.4. The heaviest was disqualified. All right, here's how we're going to do this. I like to do these with sums. So I say that the original sum is if there's 10 pumpkins that the average was 18.4, then if I just multiply them together, 184 is the total number of the weight of all the pumpkins because it's the average divided by 10 gave me 18.4. Or I could just pretend that all 10 pumpkins weighed 18.4. So then multiplying them gives me the sum. So the heaviest was disqualified and removed. Okay. Now the mean weight so the new sum is just 9 times 16. Because again, there's 9 pumpkins that have an average of 16 pounds. So 9 times 16 is the sum. So now I can see that it went from 184 to 144. So it must have been a 40-pound pumpkin that was disqualified because my sum went down by 40. Okay. So here we're going to do the sums as well. So for data set X, the sum, if you get good at this, right, you just say, okay, data set X, the sum is just multiplying these together. So 45 times 120 is 5,400. And then for Y, the sum is 55 times 80. So it's 4,400. And then Z, the sum, well, these were just added together, right? So the sum would just be 5,400 plus 4,400, and that is 9,800. And then it wants the mean of them. Well, there were 100 total, right? So we just divide that new sum by 100, and you're going to get 98. All right. So if you multiply however many data points there are by the mean, that gives you the sum. All right. That's like that to me that I'm always looking for that when I'm doing problems like this. Okay. So we have data set Q that consists of 65 integers. Between that amount, data set R consists of all the integers in the data set Q as well as the integer 600. Okay, which of the following must be greater for Q? All right, so R is everything in Q and then a number that's bigger than any of the numbers that were there. So what that is going to do, which of the following must be greater? So we know the mean has to be greater because if the new number that we're introducing is larger than the mean, well, this is larger than every number that's in the data set. So it's definitely going to move the mean up. Now, what's going to happen is there's going to be a number that's in the middle because there's an odd number of integers. And then when we put a new integer, the median's going to shift up a bit. It's going to really be the average of now two numbers that are in the middle. The thing is, though, if the number that is the median and the one above it are exactly the same, then the median won't change. And the thing it says is that it must be greater. So if you think of a smaller example, like imagine we had 2, 4, 4, 4, 5. Okay. The median is 4. Okay. Now let's say I add a new thing to the data set, 6. Well, now the median is between 4 and 4, which is still 4. Okay. So it is possible but the median doesn't change. It's also possible that it does, but it doesn't have to. So what must be greater for Q? Well, the mean has to be greater, but the median does not have to be. So the answer is one only. All right. So Liam and Sophia, they jogged for 6 days, and the distances they ran are shown here. The mean distance that Sophia jogged. I'm just wondering why this one's so much bigger, but it doesn't matter. Okay, yeah, it's just 1, 2, 3, 4, 5, 6. Yeah, they made this one so much wider. I thought that like had meaning, but I guess that's typical SAT. Okay, so is zero point 0.4 miles less than the mean distance that Liam jogged? Okay, so let's find the mean of Liam. So I'm just going to do this in the calculator. So I'm just going to add them up. And get a total of 29.4, and then I'm going to divide by 6. So Liam's mean is 4.9. And then we have Sophia. Well, Sophia's mean is 0.4 less than the mean distance Liam jogged. So Sophia's mean is going to be 4.5. Okay. Now, what is the value of x? Well, now I can find the sum by just multiplying this by 6, right? So if her mean is 4.5 and there were 6 different data points, then 6 times 4.5 is going to be her sum. So her sum is going to be 27. And then I can simply just add these together. So 4.6 plus 3, whoops, plus 3.9 plus 4.8 plus 4.2 plus 4.1 is 21.6. So her sum is 21.6 plus x, and that has to equal 27. So 27 minus 21.6 is just 5.4. So the value of x on this distance is got to be 5.4. All right. And finally, we have two groups and a frequency distribution for the 15 students. Oh, 15 in group one, 17 in group two. Okay, got it. So the median score in group two. All right, so here's how we're going to do. This is how I do the median. You can do it a little differently because the numbers are smaller, but I'm just going to show you a way to do it. So even if these numbers were huge, it would still be just as easy. So for group one, I'm going to do 15 divided by 2 is 7.5. So I'm just going to start adding these up. And the first row that puts me over 7.5 is going to be the row that contains the median. All right. So I do 3 plus 4 is 7. Not there yet. 7 plus 2 is 9. Now I'm there. So the median for group one is 3. Now I do the same for group two. So I go over here and I say, all right, so for group two, there's 17. So 17 divided by 2 is 8.5. All right. So now I go 1 plus 1 is 2, 2 plus 1 is 3, 3 plus 2 is 5, still not there. 5 plus 3 is 8, still not there. 8 plus 4 is 12. This one is the one that put me over the halfway point. So the median must be 6. And then it's how much greater? 6 minus 3 is 3. All right. So again, it really is because like if it's 7.5, then if I round that up, the eighth value would be the median. So the one that contains the eighth value. So it's the one that puts you over that is going to be the one that contains it. Because, remember, like think about this one. We got to the eighth number, but we weren't at the median yet. And then the next four numbers were all sixes. So one of those sixes is the median. All right. And same thing here. One of those threes, one of these two threes is going to be the median. It'll be the first one, but it doesn't really matter. So it's whatever row puts you over the halfway point is going to contain the median. All right, that is it for today. So, as always, check us out. This one will go on YouTube. I'll splice it up for TikTok. Remember, we offer one-on-one tutoring and we have 8-week prep courses. So, any more information, just call or text. And again, thanks for coming, and I'll see you next Monday.